All right, let's get started. I'm Brian Yencho. I'm a member of the Livefront team. I'm here to talk today about why everybody hates Nougat. But first, there's a couple of warnings I just want to let you to know. Don't know how many of you have seen the Dropbox redesign, the re-update, but I kind of took a little inspiration from that because I liked how they took something that was maybe inherently boring, like cloud storage or custom Android exceptions, and jazzed it up a little bit with a whole bunch of garish colors, and then a bunch of bold typography in black and white. So we're going to see a little bit of that today. Another warning is that the second half of this talk is really just kind of a shameless plug for a library that I built to kind of fix the problem I'm going to talk about. But I built it for people to use it, so I just want to let you know about it. All right, so this is really a story about TransactionTooLargeException. So what is this? It's a custom Android exception. It first appeared in Ice Cream Sandwich, which was quite a few years ago, API 15. But the behavior that it's kind of encapsulating has been there as far back from the beginning of Android, as far as I know. So let's take a look at what that's all about. So let's say you have your main screen here, list of items, and maybe tapping on one of those items takes you to a detail screen. Now, in Android, the way we do this is we fire up an intent. So if we take a look at this, normally what you would do is you'd say, I want to go to this detail screen. So you build this intent, you say start activity, everything's fine. But let's say you want to put some data in there. You could put all kinds of data in intent. But let's say you want to put something that's really large, like some really large bitmap. After a certain point, this is actually going to cause you a problem, and this won't work. And so what's going to happen is you just won't navigate to that next screen. You're going to see this message on some versions of Android, some older versions. You'll see this failed binder transaction message, and then you just won't go anywhere. On newer versions, you're actually going to see this TransactionTooLargeException, and this is going to crash on you. One way or the other, you're not going to that second screen because you tried to put too much data in this intent. And so this all comes down to this transaction here. So let's talk more about what that is. It's these binder transactions, and a couple years ago here at DevFest, I gave a talk that was almost entirely about this. So this year I kind of challenged myself to do this a little differently, and just in sort of a more shorter form. So let's talk about what these binder transactions entail. Let's say you have your app, it's in your process, com.yourprocess is sort of evocative of a Android package name. For no particular reason, this is going to be represented by a silly photo of my cat. Now, for these binder transactions, what happens is your process and your app is going to talk to the system process. This is where all the Android operating system stuff sort of resides. And again, for no particular reason, this is going to be represented by a bug droid lawyer. OK, so let's take that example of going from this one activity to the second one. So the first activity in your process is going to say start activity. And it's going to build this intent. I'm going to represent this data that it's going to pass by this dollar here. So this is going to send it over to system process. It's going to take a look at it. It's going to say everything's good. It's going to send it back. And we're going to use that to start our next screen. Now, every time we pass data back and forth here, we were doing a binder transaction. And this is a way we communicate from one process to another on Android. So just a little more about how this works. You're going to start with something like an intent or a bundle. This is going to get written to a parcel. This is a very optimized object it's for this inter-process communication. It's going to be part of this binder transaction, come out on the other side, other process, and it's going to write it back out into the initial object that you were looking for. The key idea here is that there's a 1 megabyte buffer for all these transactions that happen originating from your process. So let's take a look at our example of just trying to send a little bit of data over. What needs to happen is this is going to go, and we got to make sure that we don't overflow this buffer. Everything in this buffer can be dealt with. But if we start with a buffer that's already a bit full, and we try to pass something that's a bit too large, we're going to hit this buffer. It's going to say, that's too much. We're going to get this transaction too large exception. And the key here is it's not necessarily that each action that you're taking that triggers this is because you tried to send 1 megabyte of data. It could actually be much less than that. It's just that there's other things that are in the buffer, and then your piece of data just pushed it over the edge, and so it was denied. So often when you see this transaction too large exception, it's more like half a megabyte or even less than that. All right, so that's why in this example here, trying to go from one screen to the next, if you put too much in an intent, it's going to fail this binder transaction, and this isn't going to work. As a developer, this is unfortunate, but you realize this pretty quickly. You try this once with something that's too large, and you kind of get the idea, like whether you got the crash or you got the silent error, you're not going to the next screen. Now I want to take a look at saving state and how this kind of plays into the same kind of concept. So let's say we have our first screen here. At any point on Android, you could background your app, and the system might kill it, and you might want to restore the state of that app. And Android has a whole system set up to do that. So you could get this process death, but you've saved state in your app in a certain way that you can come back, and your app appears to be how you left it. So every time we go from one activity to the next, we get an opportunity to save the state of the activity that we're leaving. And so this happens in that onsaved instance state method. And then every time that gets called, then we're going to stop that previous activity, and we're going to move on. Another way this can happen is with configuration changes. So you can rotate your phone, and this actually triggers those same things, because on Android, by default, when you trigger a configuration change, like a rotation, basically all your activities and all your fragments are going to get destroyed, and they're going to get rebuilt. So before we leave, before we rotate, we're going to have these same calls to onsave instance state and onstop. All right, so let's see how this kind of works. We have our main activity here, and let's say our data is represented by this list of something I'm just calling a data model. This data model, the important piece is that this implements this parcelable interface. Now, I want to just kind of give a quick example of like why would you save this data, because I'm going to show how we save it in a second. Let's say every time you load up the screen, you call load data, and maybe that's a network request, maybe that takes a while. Once that completes, you get your data, you store it in this data list here. But let's say you don't want to do that every single time the screen starts up. So we can say, if we already have the data, just show it. And so this is nice. So we can use this to tie into the saved instance state framework here. So we can say, OK, on save instance state, put the data in here. If we background the app, if the app gets killed, process death happens. And when we come back, we try to rebuild everything. When the screen gets created again, we can pull that data back out. And then once the screen starts, we're all good. We don't have to make that network request again. We can say, I already have data. Just show my data. Now let's look at this picture of the cat and the lawyer again and see how this plays out. At some point, the system's going to say to this one activity, all right, you're stop now. Whether you're going in the background, whether you're going from one screen to another, or you're rotating. So your screen and your process gets this onsaved instance state call, and that's called onStop. In onStop, we're going to take the bundle that we constructed in onsaved instance state, pass it over to system process. And that's so the system process can hold on to your data and give it back to you if you might need it. But we've done one of these binder transactions again. So then the question is, can you pass too much data in this onsaved instance state? And the answer is yes, you can. Now, what happens if you do that? And I'm going to draw a line here on Nougat. And this is where Nougat finally comes in. All right, so pre-Nougat, what would happen if you put too much data in there? You try to navigate from one screen to the next. It seemed like everything was good. As far as you were concerned as a developer, you tested it out. Seemed like it worked fine. After Nougat, you get this hard crash. and it's going to be this transaction too large exception. And this is something that if you weren't aware of this, if you weren't prepared for this change in Nougat, this was very frustrating. It turns out that if you were being very careful before Nougat, you would actually know that you were doing something wrong before. You'd see a little log in your log statements saying that there's a failed binder transaction. So you were doing something wrong, but the system wasn't crashing, and it wasn't preventing you from moving to your next screen. It wasn't preventing anything bad from happening, as far as you can tell. So there was a warning for this. If you read the release notes of Nougat and the things that changed, they did warn you that now all of a sudden they're going to start throwing transaction too large exception more often now, and specifically for this on-saves instance state. So they kind of knew that this was coming. But one thing I want to point out is that it's not necessarily even something that you did wrong by putting too much data in that bundle. The system itself can actually have this problem. So there's a variety of views in Android that save their own state. So if you have a switch, it'll remember if it's toggled on or off. If you have an edit text, it will remember the text that you put into it. And it'll save that and it'll restore that. There's no bound on how much text you can actually put into an edit text. So I wrote up a little dummy app here to test what would happen on Nougat. So we have an input field here. We have the first button here is going to write one chapter of Moby Dick. And the second button is going to navigate to another screen just to see what happens. So if we run this here, we're going to write a chapter. We'll write a few chapters before we start testing navigation. So there's 136 chapters in Moby Dick. Does anybody have any idea at what point this breaks down? Any guesses? Well, it's going to break down at, it's almost here, chapter 14. So you can get about 10% of the way through typing Moby Dick into an edit text before just the naive implementation of the edit text in the system will crash itself. And you might think that, you know, that's sort of, nobody would do that. That's sort of an extreme example. There's a WordPress app that actually has that exact problem, because you can type long posts into WordPress, and you could download them from online onto their app, and you could edit them in the app, and then they have that problem. It can crash. So this is why I say everybody hates Nougat. I personally found this very frustrating when I started seeing this issue. Maybe I'm overplaying it a little bit, so I technically should say that people affected by transaction too large exception hate Nougat. Hate is so strong, so it's really are frustrated with. But you know, that didn't really make a very great title. People affected by transaction too large exception are really frustrated with Nougat. So that's why I say everybody hates Nougat. But I did find it very frustrating. So the question is, are there solutions? Are there ways around this problem? So let's kind of go through some options. One option is don't save state. And I think this is what a lot of people did when they were sort of taken off guard when their apps started throwing transaction too large exception on Nougat devices. And sometimes this is all you can do. And I know that on at least one app for a brief period of time, this is what we had to do. On a few screens where there's too much data before, we just had to say we're not going to do that anymore. That was unfortunate. This is sort of a strategy of last resort. If there's nothing else you can do, is don't save state. I find that unfortunate. I always thought this, you know, state saving on Android was a very cool thing, but you might resort to just not doing it anymore to get around that crash. The answer moving forward, given by Google, is to use the Android architecture components. Use ViewModel, use Room, or some equivalents. Use something that sort of serve the same function as these. All right, so ViewModel. The main idea here is that, let's talk about configuration changes. When you rotate the app, your activities and fragments are going to get destroyed. The idea behind ViewModel is that you can attach something to them that will manage some of their state that they won't get destroyed. Because when you go through a configuration change, the process still lives on. So if you have any singletons, or if you have any long-living objects, they're not going to go away. They'll still be there. So you can attach these models back to your activity or fragment, and you can get that state from them. That's only going to work for configuration changes. Now, if you want to actually deal with process death, if you want to be able to background your app, the OS kills it, and you want to be able to restore it and get your data back, you actually need some kind of data persistence. That's where something like Room would come in. This is just a nice wrapper they made for writing to SQL databases. So this is really the strategy moving forward, I would say. There's actually a very nice Medium article about this by Lala Fujiwara that kind of deals with this exact problem, what to do moving forward now that we have view model, and how does this interact with the original onSave instance state method, and how does Room come into play. So if you kind of want that answer moving forward, this is just a really, really nice, succinct blog post that really kind of explains it all. But not everybody is in the, has the ability to start on a brand new app with a brand new architecture. Not everybody can take the app that they have and immediately convert it to a new architecture like that. So if you need to get around this crash, you have to do something. And you might not be able to do something as drastic as rewrite a whole big chunk of it. So what I'm going to talk about is using some kind of workaround just to get around this problem for now. I call it a workaround. You might think it's kind of a hack. It's going to depend on what you think of it, but what I'm going to do is outline a kind of solution. So let's take a look at the situation we were before. We had our data model list here, and we're saving it and restoring it in onSave instance state. Before I sort of lay out a solution, the first thing I want to talk about is a library that I really like that I've used in a few projects called icepick. What this does is, rather than having to just write up these random keys to put into bundles, you can just annotate the things you want to save. And then with these calls to save and restore instance state, it will just populate or read the data that is annotated. So it's just really nice. I've always liked working with this, so the question is, can we build a wrapper for this? Can we build something that works very similar to this, but that just doesn't have this crash? So I'm going to lead you through some steps to build something that, for this talk, I'm going to call State Manager. So let's build out this State Manager class. So the first thing we're going to do is deal with the case of configuration changes. All right, so our State Manager class, I just have to do some due diligence to just set up that, yes, it's kind of like a singleton. We're just going to make this singleton instance. And our two public static methods is going to call through to that. But really what we're interested in is building out these save and restore methods. All right, so let's start with saving state. All right, so the key idea here is what we're going to do is every time we save state, we're just going to generate a random UUID. Now, for our save state method, I've named this bundle getting passed in the activity bundle. So that's the bundle that normally you'd be putting stuff in. So what we're going to do instead of putting all our state into that bundle, we're just going to put a UUID into that. We're just going to put this, basically just a tag that we can grab later for identification purposes. So that's the only thing that we're going to put in our bundle now. Now what we're going to do is we're just going to make our own bundle, and we're going to leverage icepick for this example. And we're going to use icepick to actually save our state. But it's going into this other bundle. And this other bundle, we're going to hold on to it ourselves. So as I mentioned for configuration changes before, the process stays alive during a configuration change. So if you have any singletons, they're going to stay alive. They're going to be fine. So in our state manager singleton, we're going to have this UUID bundle map, where we take this UUID that we just generated, and we're going to use that as the key to the bundle that we've constructed ourselves and saved. So now if we go to the restore method, if we don't have an activity bundle, don't do anything. But if we do, the main thing here is we're just going to grab that UUID that we put in there before. That's the only thing we need from it. So we're kind of leveraging the save state system just to hold on to this one identifier for us. And then we use that identifier to get the bundle that we put in into our map. And if the bundle's there, we just use icepick to restore state. So for configuration changes, this totally handles saving and restoring state in a way that doesn't in any way attempt to send it to the OS. But I want to deal with the harder problem, too, of process death. Now, you might suspect if your process gets killed and you want to restore some of your state, really the only way you can do this, and this kind of goes back to the Android architecture components and the ideas there, you need some kind of data persistence. So I'm going to sketch out just a quick persistence layer here. So I have this interface disk handler. The main things we need from it are, given a UUID, it's got to be able to read back a byte array. And we need to write a byte array and pair it with a given UUID. And we also want some way to clear all the data that we've written. So there's a bunch of different ways you can implement this. I'm going to use one way that my library kind of used, and it's got some nice features. And it's kind of pushing the limits of what you should be using this for. So I'm going to use shared preferences. You're not supposed to put large amounts of data in shared preferences. But I'm going to do it just for a few good reasons. So I'm going to make a private instance of shared preferences that's only going to be used by this class. Key thing here is this is now going to require a context. So we'll see how we're going to need a context later to actually instantiate this. OK, so to write to disk, like I said, we're going to be given a UUID and a byte array. You can't actually write a byte array to shared preferences, but you can write a string. So I'm going to convert that byte array, base 64, and code it, just to get a string out of it. And then I'm going to put that string with my UUID as the key into shared preferences. And then I'm going to apply the change. This is one of the nice things about using shared preferences here, is that by using apply, you're not actually writing on the main thread. And it's doing some caching so that if you immediately try to read back, you could get the value. So that's writing to disk very easily, technically 2 lines of code. All right, so let's read from disk, just pretty much doing the complete opposite. Use shared preferences to get the string for our UUID. If it's there, we're gonna base 64 decode it. That's gonna give us a byte array back. And then clearing, again, really simple using shared preferences, just clear and apply. All right, so how does this affect our state manager singleton? Well, we need a context now. So what we actually need now is we need a way to initialize this singleton with our context. There's a bunch of stuff you could do here to make this a little more thread safe, but I'm just, just sketching it out here. So we have this initialize method that'll make our instance, and in our instance, we're going to get our disk handler reference given our context. All right, so now what I want to do is take the solution from before and just tweak it slightly to give it that persistence layer. So for the save state method, all that really means is adding one more call here to save the bundle to disk. So everything's the same, but after I put it in my map for safekeeping and memory, I'm also going to write it to disk. So let's work out what this write to disk method is. All right, so parcels are very optimized. So the first thing you do is you want to get a parcel, and you do that with parcel obtain. And then we're going to write our bundle into this parcel. Now, here's the key here. We're going to get a byte array out of our parcel. This is what's kind of nice. This is a little trick. We're going to use this method parcel.marshal. Given a bundle, it's going to give you a byte array back. There are certain things you can put into a parcel that will make this crash. But for anything that you'd be working with, for the most part, this works just fine. So it doesn't matter what your data looked like, as long as you had your nice parcelable models and you saved them to your bundle, you can write it to a parcel, and this will give you a byte array. So you don't have to worry about doing anything complicated to actually persist your models when you do it this way. Once we have that byte array, we just write it to disk with our disk handler, and then we recycle the parcel. So I just said that the magic kind of happens here with this Marshal method. And the first thing you'll see when you look at the documentation for this is they say totally don't do what I'm telling you to do here. They say you must not place this in any kind of persistent storage. But the reason they give, I think, is very helpful, because what they say is, because it's so highly optimized, they can't guarantee that from one Android version to a next, that if you try to read that parcel back, that it's going to be in the same format, that that's actually going to work. Now, our strategy here is going to set this up in such a way that we would never be in that situation. You're never going to try to read it back from one Android version to a next. This is technically, we're writing this data to disk, but only temporarily. This is just to handle these quirky save state issues. So I took a look at this, I note it, and I move on. All right, so that was writing to disk. Now we're just going to look at how do we restore from disk. And again, we start with what we had from before, our sketched out solution, and we just tweak it slightly to just get that extra piece to restore from disk. So we started out by just giving the UUID to the bundle map, seeing if there's a bundle. Now we're just going to see if it's not there, then try reading from disk instead. And it might not be in the disk either, but that's just our second step to check. So now we just have to sketch out this read from disk method. OK, so given the UUID, we just go to our disk handler. We say, give me my byte array. If we don't have a byte array, we don't do anything. If we do, then we do the reverse process as before. We obtain our parcel, and then we call unmarshal. This is just the complete opposite. So we give it bytes, and it gives back, it feeds the data back into the parcel. And then we know, technically the system, when it deals with parcels, it's writing tags to say, like, what's the first piece of data in here? But we know what the first piece of data is because we put it there. We know it's a bundle. So we can just use these 2 lines to say, start at the beginning and read this into a bundle. And then we have our bundle back. So this bundle that we wrote to disk as a byte array, we just read it back. Now we have it back. And we can just use this to restore our state again. Now, a key idea here, when you're reading from disk, depending on how you implement this, and I'll talk about the implementation with shared preferences, depending on how you implement the disk handler, you could be blocking the main thread at some point for some period of time. And that's kind of your trade-off. You are doing something you kind of shouldn't do, which is reading from disk on the main thread, but you're getting around this crash. That's sort of the trade-off you're getting with this workaround. Now, with shared preferences, what this is going to do is when you instantiate that shared preference object, that's going to immediately start reading from disk everything that it's responsible for. And it only blocks if it's still reading the first time you ask for that data. So in practice, the way this solution is going to work using shared preferences, it will basically add a little bit of startup time to your app. So as opposed to spreading it out and maybe adding a little bit of jank going between screens, it's going to just do it all up front while your app is initializing and maybe taking a little startup time for itself anyway. So when I tested this, depending on the size of data you put in there, this could be 50 milliseconds, maybe 100 milliseconds. I tested by putting a lot of data in there, like 50 megabytes of data into a bundle, just to push the limit to this and see how it goes. That was maybe like 1 or 2 seconds. So you're not going to put 50 megabytes of data in there. You shouldn't put 50 megabytes of data in there. So I think 50 to 100 milliseconds is worth getting around this problem if you're getting these crashes. All right, so the final step here is clearing the data. And this is kind of the part that makes it OK to ignore that whole warning about using that Marshall method and writing to disk. So normally, from before, when we say restore the state, whoops, sorry. If the bundle was null, well, we just did nothing before. But now we're actually going to use that as a flag for something that we should be doing. Because what we can say is, in a given process, if your app has one process, and that one process is the only one that deals with activities, or it has multiple processes, but there's still only one process that deals with UI and activities. You can say that the very first time you get a null bundle passed into this method, if this is used properly, you will know that the app is not restoring state. So if the app is going to restore state, all your activities are going to get some kind of bundle. And if it's not restoring state, you'll get a null bundle. So you can use that as a trigger. And you can say that for my singleton, I'm going to initialize this with this is first restore call true. I'm going to say that the very first time I get a null bundle in restore state for this singleton, I know that this is the very first time, and this is safe for me to say that we can clear all the old data that we were holding on to, because all the old data was relevant to the previous session that is no longer relevant now. And so this is what saves us from one, continuing to store too much data, and two, worrying about these issues with trying to read a parcel back on different versions of Android. Okay, so I just sketched out this solution. And so this does give us what we wanted when I sort of started this out, which is we took something like icepick and we built a wrapper for it. And it works the same way icepick does, because we eventually call icepick, but it just gets around this one crash, this one troublesome crash. Now, this is where we come to the library that I was talking about that I was going to plug called Bridge. So I built basically this exact thing, but it's done a little differently. It's got some additional optimizations, but it looks exactly like this. It's just Bridge, save, and restore instance state. You can find that on the Livefront GitHub site under Bridge. Now, there's a few more pieces to Bridge I'll just talk about real quick. One is that one of the things that I do that I didn't sort of sketch out was trying to handle the clearing of data much more aggressively. Because if you can clear out data that you know you don't need as quickly as possible, then you don't have to worry about loading it when you come back. And that just reduces that amount of time you have to spend reading, basically reading on the main thread. So what Bridge does is if you have put this clear call in on destroy, it will be smart enough to know, are we calling on destroy because it's a configuration change, or are we calling it because you're legitimately leaving this activity? And if it knows you're legitimately leaving the activity, it will clear any data that was previously saved. And there's a bunch of other stuff that Bridge does internally too, to try to just delete data once it knows it doesn't need it. The other thing I mentioned is that there's this, we need to pass a context. We need to initialize the singleton so that we can read and write from disk. So Bridge has this initialize method. So here's our context we're passing in. It's also got this one more argument here, which is a save state handler. So Bridge actually doesn't make any assumptions about what you're trying to wrap. What's the fundamental thing that's getting called to save the state? So you could be using icepick, which I do in this example. But you could also use another library. So State Saver is a library made by the people at Evernote. That's basically a copy of icepick, but it works with Kotlin. So if you want to use a different library, you can just plug that in right here. If you don't want to use one of these annotation-based libraries, you could easily come up with a solution where any object you want to save state, you would make it implement some interface. All right, so that's it. That's Bridge. So just a few final thoughts here. All right, so this problem isn't going to go away. If you look at some of the Stack Overflow posts and some of the issues posted to Google, people are like, when are they going to fix this bug? And it's not a bug. This was totally intentional. If you see this crash, it's because pretty much you were always doing it wrong. They just weren't being aggressive enough at showing you that you were doing it wrong. And so they finally decided to just cut it off, and we're going to throw this crash, and you should really re-architect your apps around this. One thought I have had, which is they could mitigate this a little bit by just making that buffer a little larger. As far as I know, when they made that buffer 1 megabyte, it was a long time ago. Devices were very different then. The main reason you have that buffer is for speed concerns and memory concerns, and Devices are different. So if you made that buffer a little larger, this would at least mitigate it for some people that haven't had time to fix their apps. I don't know if they're going to do this. I've seen this suggested, though. In the long term, what you should do is use some kind of strategy that uses view, model, and room, or something that works like them. There's really no way around it. Use data persistence if you want to be saving state. Don't abuse the save state framework. Don't put too much data in there that you shouldn't be putting in there. In the short term, though, use bridge if you have the problem, and you just need to get around it right now. And you want to get around that crash, and you're willing to make the trade-offs that I've described. All right, so thank you. All right, any questions?
Are you worried about Google putting in a limitation on the shared preferences?
Right, yeah, that's a good question. I mean, if they did, so shared preferences, it's just XML files with key value pairs. If they put a limit in there, I would change the implementation for sure. I've thought about different ways to kind of take the same concept of shared preferences, but just handle it myself with files in a way that, load all the files you need to load immediately, but then as you need them, get the data from them. So just hold them in memory after you read them. But yeah, that's a good question. And I'm pretty sure their warnings, it's kind of a similar warning, right? They say don't put too much data in shared preferences. The issue there is it's that potential to be reading on the main thread, basically, to block the main thread while you're trying to get your initial data. The more data you put in, the longer it's going to take to read that very first time. So yeah, if they ever put a limit in, then I would certainly change that. Yeah. Yes, yeah. So that's one of the things in Bridge that I do. So let's see. So one of the things I do is everything that has, every time I generate a key, I associate it with the object in a weak hash map. So it's tracking the object itself in a map. Anytime we make any call to Bridge, I check to see if anything has gone out of memory. If it's gone out of memory in that hash map for where that object was, then I get rid of all the data associated with it. So I get rid of its bundle that's in the map. I get rid of any data written to disk for it. It also gets cleared out when you call that clear method and on destroy. It will clear out anything in that bundle map too. Yeah, good question. Anything else? Anybody else? All right, well, thanks for coming. Yep.